name's Colin Trake, and for this Physics 192 video assignment, I decided to do Chapter 18, Problem 52. So right here we have a circuit, and the first question states is find the equivalent resistance between point A and B for the combination of resistors shown. So basically first we have one in a series, the top, and this is all one parallel. The top are in a series, the bottom one's by itself is in a series. Then right here is a parallel. Well, to find what the resistance for that parallel would be, I would have to take 1 plus 4, not 1 plus 4, 1 divided by 4 plus 1 divided by 8, get that total and divide it by 1, and my resistance there is 2.67, and I would add that to 3.3 to get what that series, that resistor combination would be, which was 5.97. Up top, it's already in series, so I just add that and get 3. Well, that is still, that 3 is telling us what that total resistance is up there, and that 5.9 is telling us that total resistance down here is. Well, since it's still in parallel, I need to figure out what that total resistance would be. And I would take 1 divided by 3 plus 1 divided by 5.97. And I got 2. Well, now that's in a series, it's telling us what that entire resistor is right here in that parallel. I can add that to 1 and get my REQ to 3. Here's the math broken down for you at the bottom right here. Second question states, an 18-volt EMF is connected to the terminal A and B. What is the current through the 1 ohm resistor connected directly to point A? Well, since it gives us 18 volts and the REQ for us is 3 ohms, we can actually just take Ohm's law, which is V equals IR, rearrange it to get V divided by R equals I, and take the 18 volts divided by the 3 ohms and get a current of 6 amps. So for basically trying to find what that how much current is going through that one resistor, it is 6 amps. For question C now, what is the current in the 8 ohm resistor? Right here. So for that, we would actually have to figure out how much voltage is actually going through this parallel and through the bottom sections and the top. We're really just the bottom since we're just trying to find the 8. First, we would start off and actually take the 6 amps through that one resistor, that 1 ohm resistor, and it would give us 6 volts, which means in this second series right in this second resistor right here, that means that is 12 volts going through here. And the way we get 12 is since there's a total of 18 going through it and 6 volts is taken up by that one resistor, that means there's 12 left over. Now we know that 12 is going through this entire thing. Well, we have to find out what the current is going through this bottom section. So we would take the 12 and divide it by that 5.97, which I got 2.01 right here at the bottom, or it's right next to this resistor right here, whatever one you want to look at. Okay, now we know what that is. Well, we have to take that current and multiply it by what the resistance in that parallel is right at the bottom, which is 2.67. So you multiply it, you get the 2.01 and the 2.67, and you would get a total voltage actually of 5.37 in that parallel right there. So with that, now we know what the voltage is. Now all we need to do is divide it by that resistance, which is 8. That resistor ohm, which is 8, so we would do 5.37 divided by 8, and our answer would be 6.7. Well, if we need to find out, since 2.01 is going through that entire thing, all we would have to do is the same thing for the top, which would be 5.37 divided by 4 and get 1.34, which is here at the bottom right here. And then if we add those up, we get 2.01, which is actually the current going through there. So which means for the 8 ohm resistor, 0.67 amps is going through that resistor at that point. This is Colin Trake, and this is Physics 192 video assessment.